In this session, we will learn about division of polynomials and remainder theorem. Friends, you might be familiar with the term remainder. Do you remember where you have heard it? Generally, when we divide a number with another number, we get a remainder, which at times can be 0. For example, if we divide 8 by 4, we get the remainder as 0. Whereas, if 10 is divided by 4, the remainder is 2. We can also represent this process as 8 is equal to 4 multiplied by 2 plus 0 and 10 is equal to 4 multiplied by 2 plus 2. And we can say dividend is equal to divisor multiplied by quotient plus remainder. It is important to note that when a number divides the other number completely, then it is called the factor of that number. Here, 4 is the factor of 8. We can do something similar with polynomials also. Let's first see how a given polynomial can be divided by a linear polynomial. Let's start. Find the remainder obtained by dividing the polynomial 3x squared minus 7 minus 5x by x plus 1. Our first step is to arrange the terms in the polynomial in descending order of their power or degree. That is, starting from the term with highest power to the constant term. Now let us solve using the division method. In the second step, we will focus only on the first terms of both dividend and divisor. Here, the first term of the dividend is 3x squared and the first term of the divisor is x. Now, if we divide 3x squared by x, we will get 3x. This is what we have to keep in mind each time. Now, place 3x in the quotient and multiply 3x by all the terms of the divisor. Now, we get plus 3x squared plus 3x, which we will write here and subtract just like we do with numbers. When we subtract, the signs of the terms change. Here, we will get minus 8x. Bring the remaining terms of the dividend down just like we do for numbers. Friends, can you tell what will be our next step? We will now focus on x and minus 8x. Friends, sometimes we don't pay attention to signs. Do not forget to pay attention to signs. Now let's see what we will get when we divide minus 8x by x. The number that we get is minus 8. Let's write minus 8 in the quotient place, and if we multiply it with all the terms of the divisor, we get minus 8x minus 8. When we subtract it, we are left with remainder 1. We can represent this division in the form of 3x squared minus 5x minus 7 is equal to x plus 1, 3x minus 8 plus 1. Friends, the division process will not be complete till we get the power of the remainder 1 less than that of the divisor. This means if the divisor is a linear polynomial, then the remainder should be a constant polynomial or any number or 0. Now let's find p of minus 1 for the polynomial p of x is equal to 3x squared minus 5x minus 7. We got 1 as the remainder, which is the same as what we got by the division method. And where did we get this minus 1 that we substituted in the polynomial? We got that from the divisor. And this is remainder theorem. So friends, let's assume p of x is a polynomial with degree greater than or equal to 1 and a is a real number. If the polynomial p of x is divided by a linear polynomial x minus a, the remainder we get is p of a. Now let's compare this with our previous example where we divided the polynomial 3x squared minus 5x minus 7 by a linear polynomial x minus 1 and we got the remainder p of minus 1 is equal to 1. And if the remainder is found to be 0, then p of a is equal to 0. And in such situations, a is the 0 of the polynomial. Let's look at an example for this. On dividing the polynomial x squared minus 3x plus 2 by x minus 2, we get the remainder as 0. Now, by equating the divisor x minus 2 to 0, we get x is equal to 2. and p of 2 will be 0. That means 2 is the 0 of this polynomial. So friends, with this let's end this video. In this session, we learned about division of polynomials and in the previous video, we learned about division of polynomials and remainder theorem. Today, we will solve some questions related to the remainder theorem. So, let's start with our first question. Divide the polynomial 8x cubed plus 2x squared minus 5x minus 7 by a linear polynomial 2x minus pi to find the remainder. We have to first ensure that the given polynomial is arranged in the descending order of its powers. Yes, this polynomial is in descending order. Now, write it in the division format. While writing, be careful and take the linear polynomial to the divisor place and the polynomial with higher powers to the dividend place. Friends, don't get worried looking at it. We just have to follow the steps discussed in the previous video. Now let's start the division. To begin with, we will focus on the first terms of both polynomials. When we divide 8x cubed by 2x, we will get 4x squared. We will write this in the quotient place. Now multiply the quotient with all the terms of the divisor and subtract the product from our polynomial. On subtracting, 8x cubed minus 8x cubed will become 0 and 2x squared plus 4 pi x squared will add up to form 2x squared plus 4 pi x squared. We can take 2x squared common and write it as 1 plus 2 pi multiplied by 2x squared. With this, we will carry the remaining terms of the dividend with their signs below. Now again, divide 1 plus 2 pi multiplied by 2x squared by 2x and see what we will get. We will get 1 plus 2 pi multiplied by x, which we will write in the quotient place and multiply it with the divisor. When we multiply 1 plus 2 pi multiplied by x with 2x, we will get 1 plus 2 pi multiplied by 2x squared, and on multiplying 1 plus 2 pi multiplied by x with minus pi, we will get minus pi plus 2 pi squared multiplied by x. Friends, while subtracting, the first term will reduce to 0, but we will have to give proper attention to the remaining terms. From minus 5x and plus pi plus 2 pi squared multiplied by x, we will take x as common and we will write everything else in brackets, which will be pi plus 2 pi squared minus 5 multiplied by x. Now we are left with minus 7, which we will bring down. We will repeat the same process until we get a constant polynomial or 0 as the remainder. Divide pi plus 2 pi squared minus 5 multiplied by x by 2x and we will get pi plus 2 pi squared minus 5 divided by 2. We will write this in the quotient. Now multiply this term with the divisor and subtract the product so obtained from the polynomial. On multiplying, we get the first term because we have done the calculations keeping that in mind. On multiplying with minus pi, we will get minus pi squared plus 2 pi cubed minus 5 pi divided by 2. On subtracting, the signs will change and we will get the remainders minus 7 and pi squared plus 2 pi cubed minus 5 pi divided by 2, which together will become pi squared plus 2 pi cubed minus 5 pi divided by 2 minus 7. Friends, if we carefully observe the remainder, there is no term with variable x. This means we have got a constant polynomial and hence the division is now complete. So we can say that pi squared plus 2 pi cubed minus 5 pi divided by 2 minus 7 is the remainder. This is the solution to this question using long division method. Now let's see the solution using remainder theorem. Let's assume p of x is a polynomial with degree greater than or equal to 1 and a is a real number. If the polynomial p of x is divided by a linear polynomial x minus a, the remainder we get is p of a. Let's compare this with our example. Here we are dividing the polynomial p of x by a linear polynomial x minus pi by 2. We got the remainder p of pi by 2 as pi square plus 2 pi cube minus 5 pi divided by 2 minus 7. Now let's move to the second question. State whether the given linear polynomial x minus 1 by 3 is a factor of the polynomial x cube minus 10 by 3x square plus 3x minus 2 by 3. If on dividing the two polynomials we get the remainder as 0, then we can say that the linear polynomial is a factor of the given polynomial. But how to find the remainder without carrying out the division procedure? Yes, we can. If we equate the linear polynomial with 0, we will get the value for x. Now, on substituting the value of x in the given polynomial, we can determine its remainder. So let's do it. On equating x minus 1 by 3 to 0, we will get the root of this equation, that is x is equal to 1 by 3. And now we will find p of 1 by 3. We got p of 1 by 3 as 0. What does this mean? This means x minus 1 by 3 is a factor of the polynomial x cube minus 10 by 3x square plus 3x minus 2 by 3. So friends, with this let's end our video. In this video, we solved a few examples related to the remainder theorem. See you in the next video with some more interesting questions. Today, we will learn some interesting facts about remainder theorem. In our previous video, we have already learned how to divide polynomials using the division of polynomials method. So let's solve a question related to it. Divide the polynomial x cube minus 2 by a linear polynomial x minus 1. What are we doing first? Let's write the polynomial in the descending order of its powers. Is the polynomial in descending order here? Yes, but if we look closely, we will notice that terms with x square and x are missing. In such a situation, we can write those terms by taking their coefficient as 0. And now, solving this would be easy. We have partly solved this question for you. Fill in the remaining blanks. You may also pause the video to solve this question. So friends, we hope you could solve this question easily. We end this video here. See you in the next video with a new topic.